I'm gonna know what to do. So you missed it. You kidding? Oh, you're right. Everybody started.
Can you hear me okay when I'm doing this?
Yeah.
Like when you watch the videos?
Yeah. I just feel like mumbles when students talk.
Yeah, we can hear you. Yeah.
Yeah.
Okay, so the first thing we're going to do is find the equation of the tangent line at 2 for this function. Okay, so first of all, let's just talk about writing the equation of a line. What two things must we have to write the equation of a line? Point and slope. How might we find slope? Derivatives. Okay, so let's go ahead and find this derivative. Brady, what's a derivative? Mm-hmm. Okay, Carly, help him out.
I got
Okay, negative 2x. Okay, derivative of 6 is 0, right? Okay, so then this is our derivative. What should we do with that? Plug in 2. So our slope at 2 is negative 4. Now we need a point. Okay, if we plug in 2 to the original, what do we get? 2. Right? So then, the equation of our tangent line, y minus y equals slope times x minus x. Leave it in point slope form. Leave it. Don't simplify it. That's the slope at the point. Okay? That's the instantaneous rate of change at the point. Okay? I'm hoping that these words are like ingrained in your brain. Slope. Yes. Since we're at x is 2, we can plug 2 into our function, and that's where we are on the graph.
That's where the tangent line is?
Well, that is, yes, that's where the tangent line is hitting. So if x is 2, then on our, on f of x, if we plug in 2, we get 6 minus 4. So our y value is 2. Okay, so here, let's graph it. Our function was what? Okay, so that's our function. They were asking for the slope at 2, so we figured out 2 is the point on that graph, and we found that slope. Okay. All right. Are you ready? Okay. So the first thing I'll show you, there's 2 ways to find a derivative. The first way, since I already have this graph on here, I can use it, I can find it using the graph. So if we graph the function and we say second calculate, what do you see in there? dy dx. So if I say second calculate 6, and I want my derivative at 2, enter, our derivative is negative 4. Second calculate. Okay. Now, not every time are we going to want to graph our function because they're going to be maybe crazy and you have to adjust your window. Not all the time is graphing it practical. So here's another way. Probably the way that you want to use more often.
hit click to and
Did you go to second calculate?
Yeah.
Hit six.
Oh.
There it is. Okay, now, this is probably the way you want to use most often. Everybody hit math. And then you see there's this in derive. Hit math 8. Okay. Now, if you have a TI-83, just hold on. Okay. If you have a TI-84 and this is what it gives you, okay, we're finding the derivative with respect to x, so d dx.
Yeah, how did you get there again?
Okay, everyone hit math
Oh.
8.
Oh.
So d dx, we're taking the derivative of 6 minus x squared. That slash, remember, means evaluated at x equals 2. Okay. There is a very good reason why I'm showing you how to use this feature in your calculator.
I got it.
Yep, okay. So if you have an 83 or an 84, that gives you this. Right?
I think that's the one like you're in like the graph.
Well, no, so some people are going to have this.
Oh,
Okay.
Mine did that at first, but then I like got it like a graph mode and like it clear and stuff. And then,
Okay. But regardless, 83s are like this. You're going to type in your function. Okay. With respect to x evaluated at 2. Close parentheses. Do you know how to find derivative on this?
Sort of.
Okay, do you have your like user's manual where you can look it up?
I just have one issue with it. I mean, I can do it sort of.
So see calculus, 1 and 3, differentiate into the same thing. 6 minus x, comma, x, comma, 7. You're gonna love the Bible. No, seriously.
What the heck, dude? Stop.
The answer to all the questions are you'll get 100.
No, the project, not the final, the project.
So if you
What?
don't put a comment, that's in here.
Oh my god. Oh, I got any cooking in that.
Yeah, you should be able to,
We can work on it. We can figure it out. Do you have your manual?
I actually finished this all on my own. I actually finished
I know, I saw him.
Okay.
Okay, any questions on the calculator? What?
Me.
Okay, we need to discuss the average rate of change versus instantaneous rate of change. Average rate of change is going to be the slope between 2 points, okay? It's basically the slope of the secant line. So if I want the average rate of change between these 2 points, I can find the slope of that secant line, and that represents the average rate of change on an interval. Okay? It's just the slope between 2 points. What's the difference between average rate of change and instantaneous rate of change?
average
average is from point to point and it crosses the line, the curve twice, whereas instantaneous is tangent.
Okay, the instantaneous rate of change is only the slope at a point. Okay. Okay. Instantaneous rate of change is just a slope at one point. Okay. You are going to be asked to find average rate of change and instantaneous rate of change. As long as you know that instantaneous rate of change means the derivative, you should be fine. As long as you know that average rate of change means the slope on that interval, you should be fine. Can you calculate slope? Do you know how to calculate slope between 2 points?
Run over right,
I'm gonna have to talk to your algebra teacher.
Believe you copied that.
Yeah, he copied off.
You go back.
Copied
I'll
off.
look at it. I'll get it right.
Why is it equals negative 1?
Oh, in this case.
Oh,
Okay. Here's our function. Hey, look familiar?
Oh, yeah, we just got that.
Oh, yeah. So I want the average rate of change on the interval 2 to 5. So if we want the average rate of change, what are we finding?
The average slope between each.
Okay, we need the slope between these 2 points.
You can just plug it in our calculator. Can't we do that?
Well, you have to find the slope at
Isn't
2
that-
and the slope at 5.
No, that's the derivative. Average rate of change, we actually need to know what coordinates these are. So when x is 2, what is y? When x is 5, what is y? So our average rate of change is the slope between these 2 points.
Oh, 2-5 is the interval, so that's why.
Yes, 2, 5 is the interval.
Alright.
So that's the average rate of change. So that would be, I'll come back, don't you worry.
Why can't you put them both in your calculator and averaging?
Because our derivative isn't necessarily changing consistently. Okay? So our average rate of change isn't consistently changing. Does that make sense? So we can't take derivatives and average them together. Only on this one, because the derivative of an x squared function is going to be a linear function. That's not going to work if it's cubic or quartic or anything else. Okay? But that, did you see what I'm saying though?
Yeah, if it's linear, it works, but if it's not.
Okay, because our derivatives are not changing consistently.
Like that could be the derivative.
Okay, so where was I going? We were at 5. Oh, it's negative 19 is like down here, isn't it? And then 2, 4. So we just found the slope of that line, the average rate of change. Okay? Now, we want the instantaneous rate of change at x is negative 2. What does that mean? Derivative. And we already know the derivative is what?
Oh, negative 2x, okay. I see.
Negative 2x,
So you
right?
multiply your days.
Now, the instantaneous rate of change at negative 2 would be 4.
So B is what we could use our calculator for.
Well, I would not say that this is a problem that you would need
Yeah, I
to use
know.
it for. Okay, but now you can kind of check yourself as you're doing your homework, especially on these even problems. If you're evaluating the derivative at a point, you have a way of checking yourself.
So
Okay.
where are we finding the specific line, or are we just finding the slope?
If I ask you to write the equation of the tangent line,
Okay.
you're going to write an equation of the line. Okay. If I ask for either the derivative or the instantaneous rate of change, then that's what you start. Yes.
That, equation for rate of change or whatever, isn't that x1 minus x2?
It's slope, yes.
But wouldn't it 19, negative 19 be the 5 and 2 be the 2? Or how did-
Isn't that what I did?
You did negative 19.
Y minus y over x minus x.
I know what you mean.
It's like, you plugged in 2, which is the x, and got 2, so then you get another x, and then plug in the 5, and the y.
Yeah, so we did y minus y over x minus x.
Why you do it?
So those are both x's.
Y's. Yes. Slope.
He's like asking like the 2 and the 5 like
Yeah,
in the
it's
brackets
two
are
fives.
both x's.
Yeah, so this is x to x. So that's why we plugged it in here,
To solve for y.
to solve for our y.
Oh. Well, thank you.
I thought that was both.
It's great.
At first that's what I thought.
And it says change over, so we're talking about an interval. Because we're talking about the change over an interval. Okay? Alright, how many of us have had or are taking physics?
Hey.
Alright. Okay. Here's a model for position and a model for velocity.
Should we write this down?
Sure, you get the position and the velocity I would write down. What's the relationship from position to velocity?
Displacement and displacement over time.
Yes.
Your SFG position is saying.
Yes. Josh, what do you notice?
Velocity is the derivative.
Okay. If we take the derivative of 1/2 g t squared, we get gt. If we take the derivative of v times t, we get. Okay. The velocity is just the derivative of the position. So, as long as we have position, you can just find the derivative to get the velocity function. Okay.
Oh.
Sorry. Okay. So gravity is going to depend. Sometimes we do feet per second squared. Sometimes we do meters per second squared. Physics people, I know that you're used to just meters per second squared, but sometimes we look at feet per second squared. I know that's gonna bother you. I'm really sorry. Okay. What is gravity in meters per second squared? Negative 9.8, right? What about, do you know what it is in feet per second squared?
32.
Negative 32. Okay. Now, I will give you, the book problems are going to already have the gravity put in there for you. Okay. So, let's talk about what is this V naught? Initial velocity. Velocity starting at 0. S naught. Position when we start at 0. Okay, so initial position, initial velocity. Okay? So, okay. A physics book is thrown straight down from the top of a 220-foot building with an initial velocity of 26 feet per second.
This doesn't sound like an appropriate use of a physics book.
Someone's gonna have to.
Well, someone was really angry at their physics book.
Mr. Question.
Could you imagine yourself being frustrated and throwing your book?
No,
Yeah, but not.
that's really expensive.
Not from that high?
There's no joking now.
Okay. So, I want you to think about this. If we are dropping a book, if we are throwing a book down, is our velocity positive or negative? Negative, because we are falling, right? So our initial velocity is negative 26 feet per second. What would be our initial height? Okay. Since we are in feet and feet per second, gravity is negative 32 feet per second squared. Okay, so our position equation is going to be negative 16t squared minus 26t plus 220. Okay. Okay. Let's write the velocity equation. How do we find the velocity equation? Take the derivative of position. What's the derivative of negative 16t squared? And then minus 26. Okay, we're going to use these two equations to help us. How long does it take the book to reach the ground? What are we looking for there? Time. When? Position is 0. So I need to use the position equation and set it equal to 0. What? What's that called? Quadratic formula. Now, it's possible that this can factor. If you don't want to waste the time factoring, or spend the time, I shouldn't say waste the time. If you don't want to spend the time factoring, you can use the quadratic formula. Something that I would do before you start factoring or using the quadratic formula would be to divide by, I would do more than just negative 1. Negative 2. 4 doesn't go to 26, does it? Okay. So 0 equals 8t squared plus 13t minus 110. Okay, those numbers are going to be easier with your quadratic formula. Find me those values. Do we have anything? Anything?
4.61.
4 point what?
61.
Positive or negative?
Did you get 36?
Time can't be negative, so there's one of these that will not work.
Plus one.
And I think that's the negative, there's negative 4.608. Okay, that one's not gonna work for us. We need a positive time.
What did I do wrong?
You should be getting a 2.984. Yeah?
Oh,
All over. Negative meaning with.
drawing on my calculator? Here, Mark.
Yes,
Careful.
sorry.
Did I not say that, right?
How many touches do you draw?
No, I'm not even
Oh, you forgot the parentheses. So, so you open the parentheses to the square root, right? Okay, so you close the parentheses to negative 110. You close the parentheses at the square root, but you want all of this divided by 16, so you need another parentheses to include that negative. Okay, are we getting it? Okay, what will the velocity of the book be when it reaches the ground? So what do we need to do? We just found when it reaches the ground. What am I going to do with that? Plug that time into the velocity function. Your velocity should be negative because we are throwing it down. Okay. Okay. Feet per second because we were starting with feet and seconds. Velocity is feet per second. Now, our derivative is an instantaneous rate of change. So feet is changing over time. Our height is changing over time. Feet per second. You see how that's all like related? And derivative's amazing. Carly, do you have a question?
You're right.
Do I have it?
I got that.
Okay, I'll come help you with your calculator here in a little bit, okay? Tomorrow's quiz. You will have to use the definition of the derivative tomorrow. I will specifically say, use the limit definition of the derivative to find this. I know you can use power rule, which means you should know what your answer needs to be. So you don't have an excuse to get the algebra wrong. You know what you should end up with, okay?
What was that? Did you explain it to us?
What?
Like,
You use the definition,
using the limit definition of the derivative, find the derivative of this function. As h approaches 0 of f of x plus h minus f of h all over.
Is that what we have to write down? We're not gonna have to write down like it's the slope of the. Oh, here, I was gonna listen. I was talking to you.
Okay, everyone just shut their mouths. You will have to use the limit definition to find the derivative. The limit as h approaches 0 of f of x plus h minus f of x all over h. You will have to do that. That will be the first question.
Is it
Please take a look at the quiz.
No, it's evaluating the limit.
It's not
Oh,
what
I was thinking like you wanted like a definition.
Yeah, like the slope of
That's
the.
what I was thinking.
Okay, you will have to use the limit definition to find the
There we
derivative.
go. That clears it up.
Okay, apply the power rule and your other basic rules, so sine and cosine, right? Can you write the equation of a tangent line? Can you find points of horizontal tangency? You'll get to practice that in your homework tonight. Average rate of change, instantaneous rate of change. You'll get to practice that in your homework tonight. Can you identify the relationship between a functions graph and its derivative graph? That's what you did that graph match. Those of you who have actually turned that assignment in, thank you. There's some of you still missing that.
Wait, so we're not gonna do, so we don't have to do the physics stuff on the quiz then?
Oh, yes.
Physics stuff.
Will they give you the equation?
Yes.
Can you give us like version?
So I will give you like the equation with the gravity already put in there. Okay? So, and I will give you, I'll give you the equation, okay? Now, here is your homework for tonight, except I need to add in 93 and 95. These solutions are online on my website, so you can check your work for odd and even.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, and with liberty and justice for all. Thank you very much.
You're welcome.
It's time for your Titans to
Plug in.
There is a pep rally meeting for all homecoming candidates and student council members willing to help during third lunch tomorrow, Wednesday, in room 305.
Easy chill.
Homecoming, student council was pleased to announce
Okay, hold on.
the homecoming court.
This is not safe. This is not the assignment.
Male candidates are Tristan
This is
Fairchild,
not the right assignment.
Jared Norwood,
So it's
Jared
in
Ott,
there.
Jimmy Nicola, Brian Lasky,
But that's
Matthew
not the same
Parker,
one.
me, DJ Burris, and Evan Levy. This year's female candidates are Jordan Davis.
This is your-
Krasinski, Alex Daniels, Madison Cascio, Rachel
Can you guys see that?
Packard, Tatum Peterson, McClinter, Reagan LeGrand, and Taylor Boyles. Congratulations to all of you, and we hope to see everybody October 3rd for our Around the
I know what
World
happened, sorry.
homecoming dance. Night school. Due to parent-teacher conferences this week, there will be no night school on Tuesday and Wednesday nights. Homecoming information. The homecoming dance will be held Saturday, October 3rd from 8 to 11 p.m. here at Pavilion La Vista South. Tickets will be on sale beginning
In this assignment, you're going to be practicing the power tool.
Tuesday, September
And the only
22nd
thing you
through
really need to
Thursday,
look
October
at
3rd.
would be
Tickets will cost $10 each and can be purchased anytime. So tickets will be sold at the door. After the library, stating you are cleared from all library fines and must be brought to Titan. And all outstanding class fees and fines must be paid prior to purchasing your homecoming ticket. If you are bringing a guest from another school, you must have the guest registration form filled out and brought to Titantown for approval no later than Wednesday, September 30th. Library, purchasing homecoming tickets, don't forget to stop by the library and get your approval passed first. You can take care of any overdue books, fine, and you will be good to go. If you would rather spend your money on homecoming, then fine. Follow at Pavilion La Vista South, Live